Module 2, Descriptive Statistics. Next, we'll dive deep into the language of data. Here, we'll not only introduce you to several ways of representing and organizing data but also unravel the meaning behind commonly used terms. Frequency distributions. A frequency distribution is a table that organizes data into categories, showing the number of observations in each category. Think of a bustling farmer's market. A frequency distribution would neatly indicate how many apples, bananas, cherries, etc. were sold. For example, at a local bookstore's Harry Potter anniversary event, they sold different series books in the following numbers: Philosopher's Stone 120, Chamber of Secrets 95, Prisoner of Azkaban 105. A frequency distribution would tabulate these sales figures, providing an organized view of which books sold how many copies. Histograms, polygons, and more. Frequency histogram. It's a type of bar chart where each bar represents a range of data, and the height of the bar corresponds to the frequency of data in that range. Imagine a sports stadium where each section represents a different age group. A histogram would visually display how many attendees fall into each age range. For example, a school measures the heights of students. A histogram might have bars representing intervals: 150 to 155 centimeters, 156 to 160 centimeters, and the number of students in each height range. A frequency polygon is essentially a line graph version of the histogram. By connecting midpoints of the tops of bars from a histogram, we get this continuous curve, great for comparing multiple datasets. Relative frequency histogram. This is a histogram but with a twist. Instead of showing raw numbers, each bar represents a percentage or proportion of the total dataset. For instance, rather than knowing 2,000 attendees are aged 20 to 30, you'd see that 20% are. For example, continuing with our school data, if you draw lines connecting the midpoints of each bar from the histogram, you'd trace the frequency polygon. Ogive. This is a line graph representing the cumulative frequency or cumulative relative frequency. It gives a running total, allowing you to understand the accumulation of data points up to each class. For example, if you wanted to find out how many students are below 165 centimeters, the ogive would help, showing cumulative counts or percentages up each height class. Quantitative data, stem and leaf plots and dot plots. Stem and leaf plot. This is a unique way of organizing data where each data point is split into a stem, the initial digit /s, and a leaf, the final digit. It provides a visual distribution of individual data points. For example, consider exam scores of 67, 68, 72, and 78. The stem would be the 60s and 70s, while the leaves would be 7 and 8 for the 60s and 2 and 8 for the 70s. A dot plot is a simple, yet effective, method. Each data value has a dot, and when data points repeat, dots are stacked. For example, if 10 students scored between 90 and 92 on an exam, you'd place 3 dots above 90 to 92, one for each student's score. Pie and Pareto. A pie chart is a circular chart divided into segments, each representing a particular category. The size of each segment is proportional to the frequency of the category, perfect for showing parts of a whole. For example, in a survey about favorite ice cream flavors, 50% like vanilla, 30% chocolate, and 20% strawberry. A pie chart would visually segment these preferences. A Pareto chart is a bar graph with categories ordered from most frequent to least. It's inspired by the Pareto principle, which states that roughly 80% of effects come from 20% of the causes. For example, at a tech support center, if software crashes are the most frequent issue followed by hardware malfunctions, a Pareto chart would show software crashes with the highest bar, descending in order. Relationships and trends, scatter plots and time series. Scatter plots are graphs with points plotted to show the relationship between two variables. If height and shoe size were related, a scatter plot would reveal if taller people generally have larger shoe sizes. As an example, a cafe owner tracks daily temperature versus iced coffee sales. If higher temperatures correlate with more sales, the scatter plot would reveal this upward trend. Time series charts display values against time. If you were tracking the growth of a plant, this chart would show its height changes over successive days. A plant's growth is documented over weeks. Each week, its height is plotted, showing a trend of how the plant grows over time. Central tendency, mean, median, mode, and more. Mean, often referred to as the average, is calculated by adding up all the values in a dataset and dividing by the number of values. If 10 runners complete a race at different times, the mean time would be the sum of all their times divided by 10. Also, for example, if 5 students scored 80, 85, 90, 92, and 93 on an exam, the mean score would be 80 plus 85 plus 90 plus 92 plus 93, divided by 5, which equals 88. Median is the middle value when data is arranged in ascending or descending order. In the race example, if all runner times are listed from fastest to slowest, the median is the time of the runner right in the center. In the same set of scores as we just looked at, 90 is the median as it's the third score when arranged in ascending order. The mod is the value that appears most often in a data set. If 7 runners finished the race in exactly 3 hours, then 3 hours is the mode. In a class exam scores, if most students scored 85, then 85 is the mode. Weighted mean is an average where some values contribute more than others. If some race times are more significant due to specific conditions, they'd be given more weight or importance in this mean. If final grades are based on homework, 30%, quizzes, 20%, and exams, 50%, then the weighted mean takes each segment's importance into account to give the final grade. The exams count more than the homeworks. In the next module, we'll segue to probabilities of events occurring and how to calculate probabilities.